Welcome back, guys. This is part 2 of our series on understanding internal Git mechanics. In our first video, we talked about the structure of the .git directory, how Git stores information about the objects like commit, trees, and blobs, and how does Git manage to store and retrieve the snapshot of a given commit at a given point in time. Today, we'll continue our journey to understand two new concepts. First, the notion of a working tree, staging area, and repository in Git. And secondly, how Git stores information about references like branches and tags. So let's get started. Before diving into the internal details, let's quickly understand the concept of a working directory, staging area or index, and a repository in a Git project. Inside a Git repository, we usually start from an initial state called the working directory. This represents the beginning state of our work where we edit our code and work on a feature. After our changes are complete, we want to add them to our repository. But in Git, we don't add directly to the repository. Instead, we first save our changes to the staging area, which is also called an index. We save to index by doing a git add. This action creates two types of files inside the .git folder. First, the blob objects that we already discussed in the previous video. And secondly, the index file that contains information about the current changes in staging. Once we are satisfied with our work, we promote our changes from index into the repository. We do this by committing files to Git. The commit operation generates a few more files. First, the commit edit message file that contains the last commit message. Second, the log ref under the logs directory. Here you can see that the logs contain references to the main branch. It also generates some objects, basically the commit and the hash. Finally, it updates the refs heads main with the current commit information. Let's see this in action in the next section. Let's start by creating a new Git repository. On the right hand side, we'll open the .git folder. And let's watch the Git folder for any changes. Now, let's create two files, a.txt and b.txt. So here is our file a.txt and the next one we have b.txt. So if we do a ls-al, it shows us two new files. Alright, so now we will add these to the Git and see what happens on the .git folder. And here you can see Git created first two blobs, each corresponding to a.txt and b.txt. And secondly, it also generated a file called index. Let's try to inspect this index file. So if we do a cat on index file, we see that data inside it is binary data. Let's also try to check the file type of this. And this says it is a Git index file. Luckily, Git provides us with some utility commands that we can use to introspect the index file. Let's see how we can do it. The command is fairly simple. We just say git ls files and it tells us that in the current index we have two files, a.txt and b.txt. Now you can add an additional flag called stage to get a bit more information about what's actually stored. So let's see here. And here you can see you have this hash which corresponds to a.txt and this hash, second hash, that corresponds to b.txt. If you want to get some additional information, you can also use a debug flag and this gives us a bit more information. So far, we have added our file to the index. Let's now try to commit the file. And once we commit the file, let's see what changes it brings to the .get folder. Right. On the right hand side, we can see Git generated few other files. First one is this logs folder, and here we can see logs folder points to the main. Secondly, we can also see it created a ref on commit to the main branch. Let's try to check what is inside these two files. And here you can see this points to this specific commit. And similarly, if we want to check what's inside the refs head main, and here we can also find that the current main branch points to this commit. All right, let's try to inspect this git hash and see what information does it have. Let's first try to get the type of this file, which is a commit file. And then additionally, let's try to see what's the information inside this file. Here you can see it contains a tree, and if we further investigate the tree, it contains the blobs to a.txt and b.txt. So to summarize, a commit saves our work from index or staging area to repository, and additionally it moves the repository head and the logs head to point to the latest commit. Now let's see what happens if we create a new branch. To create a new branch, we just say git checkout -b, let's say feature 1, right? And now let's inspect what does the head say. The head at this point points to refs head feat 1, and here you can see under refs heads directory we got a new feature, feat 1. Let's see what is the content of feat 1. And at this point in time, the feat 1 also points to the same commit hash which was referenced by main 1. Right. Now let's try to add a new file to this branch. Let's add this file to the staging area. And this now updates our index. And here you can see at this point in time, branch feat 1 has references to 3 directories, 3 blobs, A, B, and C. Let's try to commit this. And at this point in time, it does the usual thing by creating objects. But the more interesting thing is, what does head show at this point in time? Get -head. Head points to this, and let's do a cat on this. And here we would we can see that the hash has changed. And this, here you can see this particular commit points to this hash, this tree hash, with its parent being the commit from the main branch. So in short, any references like a tag or a branch is just a human readable reference to a specific commit. When we create a new branch or when we create a new tag, we explicitly say that the corresponding hash should be named as tag this or a branch this. And this way it makes it easier for humans to correlate a branch name or a tag name to a specific commit. So to summarize what we discussed today, a Git repository consists of three areas. First, the working directory that contains the current untracked work. Second, the index or the staging area that represents the added but not yet committed work. And finally, the repository which contains the committed work. At this point in time, the head points to a ref, which in turn points to the latest commit. And finally, we have branches that are nothing but name pointers to a specific commit. Hope you enjoyed today's session. Please let me know if there are more details that you want me to cover. See you.